Hi dear students, welcome back to the class. Today we are going to discuss a kind of question from the chapter Relations and Functions. As you can see on the board, we are given with a function f of x is equal to 2 raised to x. We have to find the following. First we have to find the range of fx, then we have to check whether f of x plus y is equal to f of x into f of y, and then we have to find the set of all x such that f of x is equal to 1. These three quantities are to be found out from the question. So, without any further intro, we shall directly move on to the question. First, let us find the range of the function f of x. As we all know, range means the set of all output values, isn't it? So, whatever be the input value, if we get a set of all output values, then we call that set by the name range. So, suppose that we are given with the function f of x is equal to 2 raised to x. We have to find the range of this function. Let me give any real number as an input value. That is, let me give any number or any scalar instead of x. That is, I can give -1, -2, -3, etc. Or I can give 1, 2, 3, etc. Even I can give 0 itself. So whatever be the value I put, the result will be a real number and particularly non-negative real number. Let us see how we can obtain that. Suppose that I put -1 instead of x, then I get 2 raised to -1 as the output value, which is nothing but 1 by 2. Again, suppose that I put -2 instead of x, then I get 2 raised to -2 as the output value, which is nothing but 1 by 2 square. Similarly, whatever be the negative value I put instead of this x, I get a real number which is less than 1 but greater than 0. So that's the case when I substitute negative real numbers. Now, suppose that I substitute positive real numbers. That is, I can substitute 1, 2, 3, or even I can substitute 1.5, 1.8, any number like that. Then even when I substitute 1 instead of x, the output value will be 1. When I substitute 2 instead of x, the output value will be 2 square, which is 4. When I substitute 3, the output value will be 3 square, 2 cube, which is 8. And similarly, this goes on like that to infinity. That means that the range will be set of all non-negative values. That means range of fx is the set of all output values. That is, whatever be the input value we put, it will result in a non-negative output value. That is, it is the interval 0 infinity. That is non-negative real numbers. Now, coming on to the second question, we have to check whether f of x plus y is equal to f of x into f of y, isn't it? Let me find f of x plus y, which is the LHS, isn't it? So I am going to find the LHS. So f of x plus y is actually what? 2 raised to x plus y. It is enough to substitute x plus y instead of x in this definition, isn't it? So 2 raised to x plus y, and by the property I can split 2 raised to x plus y as 2 raised to x into 2 raised to y, as the base is the same. So this is f of x plus y. Now let me find f of x into f of y. As you all know, f of x is nothing but 2 raised to x. F of y is nothing but 2 raised to y. See, this is the RHS, and you can see that LHS is equal to RHS, isn't it? So we have f of x plus y is equal to f of x into f of y. So this is a true statement. Now we want to find the set of all x such that f of x is equal to 1. So f of x is nothing but 2 raised to x. 2 raised to x must be equal to 1, and we have to find all such x, isn't it? We know that any number raised to 0 is 1. That is, we know that 2 raised to 0 equal to 1. And there is no other real number which can result in 1 when taken to the exponent, isn't it? So the only possible value for x is nothing but 0. Therefore, the set of all x such that f of x equal to 1 is nothing but singleton set 0, since 0 is the only possible value for x which result in 2 raised to x is equal to 1 or f of x is equal to 1. So this is the answer for the third subpart. So I hope you understood all the three parts. These are very important kinds of question. It's not necessary that the given function f of x is 2 raised to x. It can be 3 raised to x or 5 plus 8 raised to x, like that. That can be any function. So the method always remains the same. So remember this method very well, and it will help you in your exam. So in the next video, we shall discuss a little bit more difficult problems, and stay tuned for those problems and watch these videos well and be an expert in the chapter relations and functions. So we shall meet in the next video. Till then, bye bye.